Hey everyone! Welcome back to the channel. If you're aiming to become a Java developer or just want to strengthen your computer science fundamentals, today's topic is non-negotiable. We're diving into linked lists, one of the most important data structures you'll ever encounter. Now, you might be wondering, why should I care about linked lists when arrays and array lists already exist? Stick around, because by the end of this video, you'll not only understand what linked lists are, but also why they're crucial for real-world programming tasks and technical interviews. Grab your coffee, sit back, and let's get started. Section 1, the problem with arrays. Before we jump into linked lists, let's take a quick look at arrays and array lists. Why? Because understanding their limitations makes the advantages of linked lists crystal clear. Arrays store elements in contiguous memory locations, which means each element sits right next to the previous one in memory. Imagine you're storing letters of the alphabet. Let's say the first element, A, lives at memory address 123 Fake Street. The next element, B, might be at 125 Fake Street, then C at 127 Fake Street, and so on. Arrays are fantastic for random access because each element has an index. Need the fifth element? Boom, you've got it immediately. But here's the catch, inserting or deleting elements, especially near the beginning, is a headache. For example, say we want to insert a new letter at index 3. Since there's already a value there, we must shift every element after index 3 to the right to make room. For a small array, it's no big deal. But imagine an array with 1 million elements, that shifting becomes incredibly expensive. The same principle applies when deleting elements, we have to shift everything left to fill the gap. So, arrays are great for fast access, but not so great when your data changes frequently. And this is exactly where linked lists shine. Section 2, what is a linked list? So, what exactly is a linked list? Think of a linked list as a chain of nodes. Each node has two parts. Data, the actual value we want to store. Pointer, an address that tells us where the next node is. Unlike arrays, linked lists are non-contiguous. Each node can live anywhere in your computer's memory. For example, one node could be at 123 Fake Street, the next at 101 Help Boulevard, and another at 404 Nowhere Lane. The pointer in each node acts like a clue in a scavenger hunt, leading you from the head of the list all the way to the tail. The last node's pointer is special, it points to null, signaling the end of the list. Section 3, why linked lists are powerful. Here's the magic of linked lists, inserting and deleting nodes is easy. Let's say we want to insert a node between two existing nodes, no shifting required. Simply make the new node point to the next node in the chain. Update the previous node's pointer to point to the new node. Boom! The chain is complete. Deleting a node works similarly. Update the previous node's pointer to skip over the node you want to remove, and just like that, the node is gone. No massive shifting, no wasted effort. However, linked lists aren't perfect. They're terrible at searching. Unlike arrays, you can't randomly access an element by index. You have to start at the head and follow the pointers until you find what you're looking for. This takes linear time, but the trade-off is that insertions and deletions are constant time. Section 4, Variations, Singly versus Doubly linked lists. Linked lists come in two main flavors. Singly linked list, each node has a pointer to the next node only. Traversal is one way, from head to tail. Doubly linked list, each node has pointers to both the next and previous nodes. This allows traversal forward and backward, but comes at the cost of extra memory to store two addresses per node. Think of it like a two-way street versus a one-way street. You can go back and forth in a doubly linked list, but a singly linked list only lets you move forward. Section 5, Creating a linked list in Java. Let's bring this concept into code. Creating a linked list in Java is straightforward. Linked list string linked list equals new linked list. Here, we're storing strings in our linked list. And if you hover over the declaration in an IDE, you'll see that it's actually a doubly linked list under the hood. Each node knows about the previous and next nodes. Inside the linked list class, you have head and tail pointers, memory locations of the first and last nodes. An inner node class, each node stores data and pointers to next and previous for doubly linked lists. Java's linked list class also implements the deck interface, giving us methods to treat it as either a stack or a queue. Section 6, Linked list as stack and queue. As a stack, you can push elements onto the top and pop them off. Let's say we push letters A, B, C, D, and F. The top of the stack is F, and the bottom is A. Pop removes F from the top. As a queue, you use offer to add elements to the tail and pull to remove from the head. Same letters, A, B, C, D, F. Poll removes A, keeping the queue order intact. This flexibility makes linked lists incredibly versatile in programming. Section 7. Insertion, deletion, and searching. One of the biggest advantages of linked lists is easy insertion and deletion. For example, if we want to add E between D and F, we just call linked list.add for E. To remove it, linked list.remove E, no shifting required. Searching is straightforward too. Linked list.index of f//returns for. You can also peek at the first or last node, add or remove nodes at the head or tail, and store removed elements and variables. Section 8. Advantages and disadvantages. Advantages. Dynamic memory allocation. Memory is allocated as needed during runtime. Easy insertion and deletion, constant time operations. No memory wastage, no pre-allocated memory like arrays. Disadvantages. Extra memory usage. Pointers consume additional memory, especially for doubly linked lists. No random access, must traverse nodes sequentially. Slower searching, linear time for access compared to arrays. Constant time indexing. So, to recap, a linked list is a chain of nodes, each storing data and pointers. We explored singly and doubly linked lists, their advantages, and their trade-offs. We saw how Java implements them, and how they can act as stacks, queues, or dynamic sequences of data. Understanding linked lists is not just academic, it's essential for efficient programming, coding interviews, and real-world applications where data changes dynamically. If you want a copy of all the notes and code I used today, check the comment section below. And if you found this video helpful, don't forget to hit that thumbs up and drop a comment. Linked lists are more than just nodes and pointers, they're a fundamental tool that will make you a better programmer.